Today topic we're going to discuss is the stack implementation. So the topics are introduction about stack, the stack algorithm, an example of stack. So Q we will do later on. Okay, stack. Stack are dynamic data structure that follow the last in first out principles. So dynamic means that we can change the size of the stack, increase or decrease the memory utilization of stack during the execution of a stack. And it follows the last in first out principle, means the element that is added at last in the stack is the first element to be removed from the stack. So stack follows the principle of last in first out. Whenever we enter an element in the stack, at last that element with the first element that has to be removed from the stack at first. The last item to be inserted into a stack is the first one to be deleted from the stack. New element inserted to a stack is on a top location. So we always mark a location called top. With this top location, we will come to know that which element is at the top location, and either we add new element ahead of that top location, and that becomes the new element, that becomes the top element. Either if you want to remove the element, then top element will be removed from the stack. So whenever you add a new element in the stack, you always have to highlight the which element is at the top of the stack. Existing element of stack is deleted from top location. So whenever we want to delete an element from a stack, the element that is on the top of the stack, we have to delete that element only. So we cannot delete any other element either in between or the first element. So we can only delete the element that is on the top, or you can say we can only delete the element that is lastly inserted into the stack. So two operations are usually performed on a stack. One is push and one is pop. So inserting an element into a stack is called push. So whenever we insert a new element into the stack, so that inserting of new element, we call it as a push. Deleting an element from a stack is called pop. So whenever we delete the top element from the stack, so deletion of the top element from stack, we call it as a pop. So two operations are being performed. One is push and one is pop. So push is to insert an element into the stack, or you can say insert the element at top of the stack. And pop is that we have to remove the top element from the stack. For example, if you have a stack of a tray on a table, we have first tray, second tray, third, fourth, fifth, sixth, nearly about 10 trays, one upon other, one upon other, one upon other. So the table that is on the top location was a tray that we have put at last, and that tray will become the first table that we have to remove from the stack. The tray on the top of stack is the first item to be removed if you require a tray from the stack. So if you want to remove a tray from the stack, then we can remove that tray that is on the top of the stack. So this is the example of a stack. Initially, the stack is empty. So I push the first element, that is element number 1, that added into the stack. I push another element, second element again. So you can see second element is ahead of the first element. So then again push the one more element, that is 3. So 3 is on the top location of the stack. So 3 is inserted at last. The first item was 1 and 3 is the last item that I have inserted in the stack. So if I want to pop the element from the stack, or you can say delete the element from the stack, the element that is on the top of the stack will be deleted first. It means the last element that is being inserted is the first element is to be removed from the stack. So this is how we can represent a stack. Initially stack is empty, then I push first element, that I insert one element in the stack, then I push second element, then I push third element. Three elements are on stack and third is the top element. If I remove the element from the stack, then top element will be removed from stack. That is number 3 will be removed from stack. And because number 3 was added at last, so number 3 will be the first one to be removed from the stack. That's why we call it last in, first out. So some of the features of stack are linear dynamic data structure. That is a linear data structure which holds a property of dynamic memory allocation, that we can change the size of the memory during the execution of the stack. Do not consume fixed amount of memory, because we can change the size of memory, so memory is not fixed. So memory can change as per requirement. Memory of stack changes with push or pop operation. So either the memory increase with the push or decrease with the pop operation. Each push and pop operation increase or decrease the size of the stack by 1. So whenever I push the element into the stack, the size of stack will increase by 1. So whenever I pop the element from the stack, the size of the stack will decrease by 1. When stack is full and want to insert one more element to the stack, the element will overflow to the stack. So I have a particular size of a stack. Let's say the size of stack is 10. So when I push the 10th element in the stack, my stack get fulfilled. If I want to insert 11th element in the stack, that 11th element will fall down from the stack, and that falling down is called as the overflow. That I cannot insert more element in the stack because my stack is already full. So overflow means when stack is full and we want to insert one more element to the stack, then that element will overflow to the stack. Similarly, when the stack is empty and I want to delete an element from the stack, the deletion operation on empty stack causes stack underflow. So I have no element in the stack, my stack is empty. So if I want to delete an element from an empty stack, then I cannot delete any element because stack is empty. So if I try to delete an element from an empty stack, well, I call it as an underflow. That I cannot perform deletion operation if my stack is empty. These are some of the applications of the stack. The way to write arithmetic expression is known as the notation. So whenever you write a mathematical equation x plus y plus z, we call it as a notation. An arithmetic expression can be written in 3 different ways, that are infix notation, prefix notation, and postfix notation. So in infix notation, the operator is between the operand. So in this case, x and y are the operands, and plus is the operator. So operator is between operand. X and y are the operand, and plus is the operator. So to show you more easily, what is this? I can write over here. X and y are operands, plus is operator. So you can easily write over here that plus is an operator and x and y are the operands. So X and Y are operands and plus is the operator. So whenever the operator is in between the operand, we call it as infix notation. So whenever the operator is before the operand, we call it as prefix notation. First the operator, then the first operand, then the second operand. So we have to write in a particular sequence. We cannot write over here plus yx. This will become wrong. So we have to write first the operator, then the left operand, and then the right operand. So this is how we can write the prefix notation. And last is the postfix notation, in which operators is written after the operands. First the first operand, then second operand, and at last the operator. So in this way we can write infix notation, prefix notation, and postfix notation. So infix means an operator is written in between the operands. Prefix means when operator is written before the operands, and postfix means when the operator is written after the operands. So always write first operand first, then second operand, and second location. So infix notation is, in a regular calculation we write expression in infix notation. For example, a minus b plus c, where operator are used in between the operands. It is easy for us to read and write and speak in infix notation, but the same does not goes well if we go for the calculation of this infix notation in computer. An algorithm to process infix notation could be difficult and costly in terms of time and space consumption. Prefix notation, in prefix notation, operator is prefixed to operand, that is operators is written before the operands. If we have infix notation a plus b, then we write it prefix as plus ab, that operator first, operand afterwards. The prefix notation is also known as the Polish notation. So do remember this point, that prefix notation is also known as the Polish notation. And postfix notation, the postfix notation style is known as a reverse Polish notation. So prefix is Polish and postfix is a reverse Polish notation. In this notation style, operator in post is postfix to the operand. That is, the operators are always written after the operand. So prefix is called Polish notation and postfix is called reverse Polish notation. This is how we can write it. So here are a few examples over here, that how we can convert the infix to prefix and infix to postfix. The first one is a plus b. We write over there plus ab and ab plus. And the second we have a plus b in a bracket multiplied by c. So as per the principles of mathematical equation notation solving, we always give priority to the notation that is in between the bracket. So whatever notation that is written in a bracket, we always solve that first. So first we solve a plus b. So we write over here a b plus ab, then multiply by c. Or if I want to explain more clearly, so I can write over here that it will become plus ab, then multiply c. So first I solve the bracket part, then I solve this part. So this will become one particular operand. This will become, sorry, This will become one particular operand. So if I want to solve it, then multiply will come first, then that particular operand, that's plus AB, then second operand. Okay. Similarly, next one is A into B plus C. Again, I have to solve the equation that is in a bracket first. So it will become something like this: A into bracket start, as we are going for prefix, plus BC. Fine. So here is multiply. So this will become again one particular operand. First operand multiply second operand. If I want to convert it into prefix, then this operator come first, multiply will come first, then A, afterwards plus BC plus BC. So in this way, we can write the prefix of infix notation number 3. If we talk about this one, so we always has a priority of operators also. Which operator we have to go first, we have to go second. So the division is having high priority to plus. The division has high priority to plus, and we move from, whenever we perform any calculations, we move from left to right. So do remember this point, that whenever we go for the solving a particular equation, then we have to go from left to right. So we start from left location to right location with priority basis. So what will happen? The division will get high priority. It means it will become slash A B, then plus as such. Again, then there's one more division on the right side, and it becomes slash, or you can say division CD. So operator first, operand later on. So operator first, operator is a divide operator, divide first, then operator later on, AB operator later on. Same in this case, operator first, then two operands, C and D operands over later on. Now this will become one operand, this will become second operand. Fine. Again, take plus first, then the first operand, then the second operand, then the second operand. In this way, we can perform the prefix notation. Again, if we go for the next one, again we move from left to right in this case, but solve the bracket first. If I solve the bracket first, then this will become bracket plus AB, then multiply, again bracket plus CD. So I solve the bracket first. First I solve A plus B, I convert it into infix, that is operator first, operand later on. Then plus. Then second bracket, operator first, then first operand, second operand. So I solve the bracket first, then later on these two become operands, middle one is operator. So operator first, first operand plus AB, second operand plus C. So in this way, I can write the prefix notation from this infix notation. Finally, the last one. So we have a bracket in bracket. In this case, we are having bracket in bracket. So first of all, we solve the inner bracket, then we solve the outer bracket. First, we solve the inner bracket, then we solve the outer bracket. So how it will be done? Let's start. First inner bracket that become plus AB, inner bracket solved, multiply C and minus D. So inner bracket solved. Now turn off auto bracket. So this will become one operand, that become other operand. Fine. So it means this will become, sorry, uh, this will become multiply first, operator first. First operand is AB plus AB, and second operand is C. Fine. So auto bracket solved minus D. So in this way we can solve the first inner bracket A plus B. I solved inner bracket from infix to prefix, that plus AB. Then outer bracket, this one become one operand, plus AB one operand, C second operand, operator first, then first operand, second operand. So auto bracket solved. And later on this become one operand and D becomes second operand. Operator is minus first operand, and then second. So in this way we can convert the infix notation to the prefix notation. Similar concept is used in case of postfix. Instead of putting the operator first in the postfix, we put the operator after the operand. So I hope you will try by yourself that if we are having A plus B, then first the operand A, then operand B, then operator C. Again, if we are having this one, first we solve the inner bracket, then we solve the outer bracket. If I talk about inner bracket, that it will become AB plus, then C, and then operator. Right? Again, in this case, first solve the bracket. So I will write over the BC plus, it will become A into BC plus, A is one operator, BC plus second operator, then A operator first, BC plus second operator, then A first operand, BC plus second operand, then the operators multiply in between them, that is in the last. So in this way we can create the postfix notation from the infix notation. This is how we can convert the infix to prefix and infix to postfix. And let's move further. Then here are the operators priority. Which operator has the highest priority? So precedence and associativity determines the order of evaluation of an expression. So this is exponential. The ES is not S, it's X. Exponential is having the highest priority in terms of operators. So whenever you have a notation in which you have multiply, plus, division, subtraction, and exponential, then first of all solve the exponential. That's the highest priority. Then second is the priorities of division and multiplication. If you have multiplication, division, and plus minus, then you have to give the highest priority to the multiplication and division, starting from left moving towards right. And the last priority we give to the addition and subtraction. Again move from left to right. So this is how we can give the priority to the operators whenever we use some notation and want to convert that notation from infix to prefix or infix to postfix. Always do remember the priority. So when an operand is in between two different operators, which operator will take the operand first is decided by the precedence of an operator over others. So as multiplication operator has precedence over addition, so it means the multiplication is always done first and addition done second, because multiplication has high priority to addition. Let's take this example first. 4 plus 3 into 2. What will the answer of it? If we move toward left to right, then what we do? We do that 4 plus 3, 7, 7 into 14, that become wrong answer. So first of all, we give the priority to the operator first. It means multiply is having the higher priority to plus. It means first we perform the multiplication operation. First we perform the multiplication operation. It means it becomes 4 plus 3 into 2. We perform this first. It becomes 4 into 6. Sorry, 4 plus 6. And the result will be 10. Fine. So always remember which operator having the higher priority to other operator. So in this equation, multiplication is having the higher priority to addition. So we perform multiplication first and addition later. So when we perform multiplication first, it becomes 6, 3 into 2, 6. We write 6 over here first. And after that, we perform the addition. 4 plus 6 become 10. So 10 will be the answer of it. Correct answer is 10. This is how we can use the priority of the operators and solve the equation. So these are again some of the examples that you can see that how we can solve it and convert them. So you can try by yourself. Don't look at these two prefix and postfix. Just look at the infix. Convert into postfix and prefix, and then compare with this postfix and prefix and check whether you have done correctly or you have done incorrectly. Fine. So try this exercise at home. Forget about this postfix prefix part. Just go for this infix part. Write these three equations: a into b plus c divided by d. First, second, third. These three equations, write on a copy. Then try to solve the answer. Convert into postfix and prefix. After conversion, then compare your answer with these answers, whether you get the correct answer or you get the incorrect answer. So if you got incorrect, some mistake might be done by your side. Fine. So try to do this exercise after the lecture so that you understand how to convert infix to postfix or prefix. Next is the algorithm to push the element in a stack. So again, whenever you write an algorithm, just write over here the name of the stack and some of the important variables that we are going to use in the stack. So let me make some changes over here. Just write start and just write stop. Every algorithm start with start and end with stop. So write over here that push underscore stack is the name of, you can say, name of algorithm, and stack is an array that we have used to design in our programming. Then n is the number of elements we want to add in a stack, and top represents the last element of stack we have inserted. Then next is the maximum number of elements that we can add in a stack. and item is the new element that I want to insert in the stack. So just write in 2 or 3 lines the introduction about the name of algorithm and the element that we have used to design the algorithm. So in simple English language, I write over here push stack is the name of the algorithm used to insert the element in a stack, and item is a new element that I want to insert in a stack, and the max is the maximum limit of a stack, and top is the top position of the stack. So how I do is start if top is equal to max. If the top element of a stack, let's say that I write over here that I'm having a stack with the maximum limit of, let's say, 10, that I can add only 10 elements in the stack, and if my top is equal to 8, it means I can still add 2 more elements in the stack. If top is equal to 10, it means my stack is totally full. I cannot add anything more. So I put a condition over here. If top is equal to max, it means my stack is totally full. I cannot add anything. If I add anything to it, it will become overflow. If top is equal to max, then print stack overflow and exit from the program. Otherwise, you can say else part, read item. User enter the element that he want to enter in the stack. So top is equal to, if let's say if stack is equal to 8, it means that stack is not overflow. The user enter the value, and let's say item is equal to 77, that I want to add 77 in the stack. So top is equal to top plus 1. What will the top will become? Top become 9, and top become 9. The stack of top, it means that stack of 9 will become 77. It means after inserting 1 more element in the stack, still I am having a capacity of 1 more element to add in my stack. So it depends upon you. You want to insert or you don't want to insert. After inserting 1 more element, so my stack get filled. So I cannot insert more element after inserting 1 more element, because after inserting 1 more element, it becomes 10. If I want to insert 1 more element, let's say I write over here 7. So stack is equal to stack plus 1. The stack will become 10, and the stack of 10 will become 7. Again, I want to insert 1 more element over here. Max is equal to top. Max is equal to top. You got a message that stack overflow. So this is how we can write an algorithm which describes that how you can design a program to add an element to a stack. From this program, we can easily understand that first we put the condition that whether the size of stack is below the value of top is equal to value of the max. If it is equal, then we cannot insert any more element. The stack will overflow. If they are not equal, it means there is some capacity to add new element in the stack, so we can add new element in the stack. From this algorithm, we can easily learn and easily understand the design, that how to develop a program. So what algorithm is? Algorithm is simple English language through which we can easily understand how to develop a program. So this is how we can push an element into a stack. So I'm having a stack with maximum size 5. Initially, stack is empty. Push A top is equal to 1. Push B, I push B top equal to 2. Then push C top 3. Push D top 4. Push E top 5. Now top is equal to max. So I cannot insert. If I try to insert more element, I put a push over here and I write over here stack overflow. that I cannot add more element into a stack because my stack is already full. So this is how we can explain how we can add new element into a stack by comparing the value of top with the maximum size of the stack. Initially my stack is empty, top is empty. I insert first element, that is A, into the stack. It means there's only one element in the stack, top become 1. After insertion of A, I add one more new element, that B, into a stack. So there are 2 elements in a stack, the top will become 2. After B, I insert one more element C into a stack. So there are 3 elements in a stack, top become 3 because C is at location number 3. After inserting C, I insert one more element D into a stack. So there are 4 elements in a stack, top become 4. So top represent the last element I have added in the stack. And after D, I add one more element E into a stack. So there are 5 elements in a stack, top become 5. So here you can see top is equal to max. The value of top is 5, value of max is 5. It means my stack is totally filled. Again, if I want to push some more element in a stack, I will get a message stack overflow. I cannot insert any more element in a stack because my stack is empty. Algorithm to pop the element from a stack. Again, write the name of the algorithm with few elements that I have used in the algorithm. Pop stack is the name of algorithm used to delete the element item from the stack at top position. So as we told earlier that we can only delete an element from a stack that is on the top. Top represents the element that is being last entered, and maximum size of stack is max. So algorithm is push stack, and top max item. So push stack is name of algorithm. Stack is an array that I have used to create stack, and is the number of element in the stack. Top represent the last element that I have added in the stack. Maximum represent the maximum size of stack, and item represents the element that is being get deleted from the stack. So start. If top is equal to 0, it means my stack is empty. If my stack is empty, how can I delete an element from my stack? So I cannot delete an element if my stack is empty. So it's become I got a message of underflow that you cannot delete an element from a stack if your stack is empty. Exit, come out of the program. Otherwise, item is equal to stack of top. Whatever the element is on top of stack will stored at in variable item. Whatever element that is on the top of stack will stored in the variable item, and not top is equal to top minus 1 because we have removed one element. Not top is equal to top minus 1, and we come out of the condition and stop the program. So you can easily understand what is the process of designing or developing a program. So whenever we develop a program, first of all we put a condition, is our stack is empty. If our stack is empty, then you get a message on screen, stack underflow. If the stack is not empty, there might be some elements in the stack, then we can remove the top element from the stack, and that top element is gets saved in a variable item that we print on screen that this element is deleted from the stack, and the top position get reduced from by one number. If there are 3 elements, after removing top element, the top will become 2. So by understanding this algorithm, we can develop the program for the stack in any particular language. So you can easily design such type of figure. If we go reverse, first we remove E element, then we remove D element, then we remove C element, then we remove B element. When we remove A element, the stack become empty. When the stack become empty, we want to perform some pop operation. We get a message of underflow. Fine. So you can draw this element design in the reverse order, in which you can mention that we are having 5 elements in the stack. So top element is E. First E get removed. Now there are 1 minus means there are 4 elements in the stack. So the element that is going to remove is D, because D is on the top. We remove D. Again, one reduction. Earlier it was 4. Now it becomes 3 elements in the stack. The element in top is C. So we remove C element from stack. If one element get reduced, now there are 2 elements. The element on top is B. So we remove B element from stack. Now we only left with one element A, because A is on the top. So we remove A element from stack. After removing A element from stack, our stack become empty. And if we try now a pop operation, we get a message of stack underflow. So you can design such type of figure for stack pop. So this is how we can write an expression for push and pop.